The complement of event A, written A with a bar over it, is the set of all sample space outcomes that are not in A. Here we see a Venn diagram, and this rectangle represents the entire sample space. And the circle represents event A. So everything outside the circle is a complement. All the simple events that are in the sample space that don't fit the definition of event A fit the definition of A complement. The probability of A complement is equal to 1 minus the probability of A. Two events, A and B, are said to be mutually exclusive if they can't happen at the same time. Here we see a Venn diagram with event A and event B, and there's no overlap. They cannot occur at the same time. They have no simple events from the sample space in common. In this case, the probability that A or B occurs is the sum of their individual probabilities. So we can write probability of A union B, which means probability of A or B is equal to the probability of event A occurring plus the probability of event B occurring. And this is the addition rule for two mutually exclusive events. If A and B are not mutually exclusive, as is the case in this picture here, where we see there's overlap, the events A and B share at least one simple event in the sample space, we can't use this rule. Consider the experiment of flipping two coins where they don't touch, so the first flip doesn't affect the second flip. The sample space consists of four possible outcomes. The first outcome is both coins are heads. The next outcome, the first coin is a head, the second a tail. The third outcome, the first coin is a tail, the second is a head, and the fourth outcome, both coins are tails. In this case, the probability of each of these events is 1/4, or 0.25. We want to find the probability of obtaining only heads or only tails. None of these four outcomes can occur at the same time. All the simple events in the sample space are always mutually exclusive. And so we can use the addition rule for two mutually exclusive events. So to find the probability of both heads or both tails, we add the probability of both heads plus the probability of both tails. So 0.25 plus 0.25, which is 0.5. Or you could represent it as 50% or 1/2. Finite sample spaces deal with discrete data, or data that can only take on a limited number of values. These values are often integers or whole numbers. Consider rolling a 6-sided die. The sample space is 1 through 6. All 6 simple events in the sample space are mutually exclusive. When you roll the die once, you're only going to get a 1, 2, 3, 4, 5, or 6. You can never get, for example, a 1 and a 3 when you roll the die once. Individual outcomes of a random phenomenon are always mutually exclusive. The probability of any event is the sum of probabilities of outcomes making up the event.